All right, in this video, we're going to look at file reading and writing, and we're going to see some examples. In an upcoming video, we'll actually do a couple in NetBeans. So, start with the file class. File class is built into Java, and its only purpose is to provide an abstraction that deals with all the machine-dependent complexities of files and path names in a machine-independent fashion. What does that mean? Well, that means that you don't have to understand how to interface with the hardware on your computer to write a file. You just create this file object that knows about the file. The file class takes care of all that complexity for you. So it's a wrapper class that basically you can think of as this. I tell the file object about the directory and the place where the file is located, and it takes care of everything for me. Once I create that file object to interface with my actual file on my hard drive or where we're at on my computer, I have a whole bunch of methods and properties that I can work with to look at things. And this is a list of them here. So for example, the name of the file .exists will tell me if there's actually a file on that there that I can do. Can I read the file? Can I write the file? Is the file actually a file? Is it a hidden file? Where is it at on my computer? Give me the absolute path. Get the name of the file, get the path, get the parent. There's all kinds of things. We'll see a couple examples of those coming up in a second. This is probably way more information than you need starting out. But here's the problem. Every operating system is different. And we know one of Java's greatest features is that it's independent of operating systems. We write it once, it can run anywhere. I can write a program, it should run on Linux, it should also run on Windows. So our objective here when we write programs is to write program how to create these files in a platform independent way and then use the methods in this file class to get their properties. So here's an example of the exact same program, one running on Windows and the exact same program running on Linux. Okay. So over here, we're looking for the primary working directory on Linux. And we're in the home directory /Liang, that's the name of the author, /book. And we're telling it to run java.test file class. And over here, we're in directory C:\book. We're saying Java run test file class. So we're running these from the command line. And it's just printing out, does it exist? Yes. Can it be read? Yes. Can it be written? True. But the real power, both of these are doing the exact same thing. When we get down here, what is the absolute path? On Windows, the file object will tell us it's on the C drive in the book directory. Go up a directory, go in the image folder, and look for the file called us.gif. Over here on Linux, the absolute path has Linux formatting, / instead of backslashes. It doesn't start at the C drive, it starts at the root drive, which is /home, and looks in the home directory. The canonical path basically removes the little dots and gives you a direct path to the file. So the power of this is we can connect it to a file, and then all these different things we can test without having to know anything about the operating system. I talked about backslash and /. We do everything with / and Java kind of takes care of this for us. And we try to use relative paths. We don't want to specify the path to a file starting with C:, and write this program on Windows, because if I actually use C:, then it won't work when it goes over and gets transported to Unix or Linux and we try to run it, it won't work. So we try to stick to relative paths and then let the file object take care of those for us. So let's look at the program that created this. Here is the program. So I said new java.io.file. So this is the file class. We're creating a new object of the file class, and we're telling it to use in the image folder from where this program is stored. Look in the image folder. So this is a relative path. There's no C:\/ or anything like that. So look in the image folder and look for an image called us.gif or .gif. Let's not argue about that today. All right, once we're connected to the file and we've given it a variable name up here, we gave it the variable name file, we can use that file object and call its methods to look at things about the file. So here we're just printing, does it exist? And we're printing file.exist. We're calling its exists method, which we learned about back here. Does it exist? True or false? And if we go back here and look at the methods, I went the wrong way. .exists returns true if the file or the directory represented by the file object actually exists. So we're calling all these methods. The file has, and we can call file.length to see how many bytes is in the file. We can call file.canRead. It'll return true or false if we can read it. Same thing for canWrite. It will return true or false if we can write to it. Is the file a directory? Or is the file a file? Is the file hidden? Get the absolute path to it. Tell me when it was last modified. In this case, we're calling file.lastModified, and then we're running it through the date class to create an actual date for that file. So there's an example of things we can do with the file. Now, nothing in here actually lets us read and write to the file. It only connects us to the file and tells us things about the file. We actually need another class to read and write to the file. We'll see that in the next video.